So now we're going to talk to you about one of the common applications of dictionaries, and that is making histograms. It's counting the frequency of things. And so if you think of a histogram as, it's a little graph, and there is, how many A's, how many B's, and how many C's, and there's a histogram that says, oh, there's this many of that and this many of that. And these are like buckets. These are frequencies, and this is how many times it happens. So a histogram. But we're going to do this thing where we're going to count people's names, and we're going to kind of count how many that we see. But the interesting thing that we're going to solve, just like many of the things in the computer, is we can't just sort of look at the data. We've got to look at the data iteratively, one piece of data at a time. So I'm going to give you a little problem. Okay, I'm going to show you a series of names, one at a time, and I want you to count for each name, make a little bucket, and then keep counting how many things for each of the different names. Okay, you'll notice that you have to start with one and then you move across. So just watch this and tell me what's the most common name of the set of names I'm about to show you, and how many do we see? So what was the most common name and how many times did you see it? That's the question. Now, here comes the reveal. So for humans, it's so much easier for you to just look at this and you think, how did my brain look at that? And you're like, okay, what is pretty common? Oh, maybe Chen is common. Oh, Chen, no. Maybe Zhen is common. 1, 2, 3, 4. Yeah, anybody else have? Marquard's got 3, C7. And so you'll notice how our minds, without computers, we just sort of like bounce, branch and bound. We have hypotheses, and then we decide, yeah, it's Zhen. That's it, and there's 4 of them. Now, how did your brain think about this as we were going through them one at a time? Well, my guess is if you really had to do this a lot, you would make a little picture like this. And then what you would do is if you saw a new name, XYZ, you'd add it to the list and give it a tick mark of 1. And then if you saw like C7 again, you'd give that a tick mark. And if you saw XYZ again, you'd make a tick mark. And then you'd keep adding to these tick marks, right? And that's how you would do it. And you wouldn't, like many of the things we do in a loop, you wouldn't really know what the most common was until the end. And then you'd sort of take a look at these numbers and you say, okay, that's the most common number, and then you'd be done. But you have to watch them one at a time. You can't just bounce around. And so that's how we're going to use dictionaries to achieve that. Again, instinctively as humans, we just look at the stuff. But if you had a million things, you probably want to write a Python program and use dictionaries. And so this is the idea, and there's 2 basic things that happen. One is the first time you see a name, you got to say, is this name there already? If it's there already, you really just want to add 1 to it, right? That's the adding of a tick. Or you want to see for the first time, blah, 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 and give it a 1. And so you can use the name as the key. And then 1 is the value. And then first time you see Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding, as soon as it sees a new name, it adds another slot in here. But then if you see the same name again, like Chen again, then you end up with a 1, add 1 to it, and so it's 2. And so at that point, Chen is 2. And so you can see how you can both extend the dictionary by encountering a new name, or adding when you see a name that you've already seen before. The problem with dictionaries is, like everything in Python, there are rules about what you can and can't do. And one of the, I think, kind of frustrating things about dictionaries is that you can't just look for a key that doesn't exist. So this is a fresh, brand new dictionary. We do a constructor there, and we print out sub C7, and boom, it blows up. And that's bad. But we can solve this by the in operator. The in operator we've used in the for loops. We've used it in lists. We've used it in strings. So that is a question. It's saying, is C7 in CCC? Well, this is this empty one, and so it is, no, it is not. C7 is not in CCC. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in. If it is there, add 1 to it. And that leads us to this bit of code. Okay, and that is the kind of code that we're going to build a histogram. This is going to histogram code. Okay, and so this is going to have name as our iterator. Names. Sorry, I made them singular and plural. That's nice, but so name is going to be csev chen, csev gen. Now normally we'll be reading this from a file, but for now we'll keep it easy. We're going to go through this, and we're going to have counts as our dictionary. So that starts out empty, and we're going to do a simple if then else every time through the loop. If the name we're looking at is not in the dictionary already, is the key, then set it to be 1. If it's not, go get the old value, count subname, and then add 1 to it and stick it back in. So this line right here is new, adding a new thing, and this line right here is adding some things to existing things. And you do this long enough, you start with an empty one, and you do this long enough, at the very end, it will print out the histogram that you're looking for, the histogram you're looking for. And so you say, oh, we've seen csev twice, gen once, and chen twice. And so that's the idea. And so this can run 1,000,000 times if you want. Now, this notion of checking to see if a key exists and doing one thing if it doesn't exist and doing another thing if it does exist is such a common practice that the dictionary object has this method called get that collapses these 4 lines into 1 line. And so the idea is you're going to do one thing if it's in there and you're going to retrieve the current thing. Otherwise, you're going to pick a default value. In this case, we'll pick 1. I mean, pick 0. This is like the default, right? Meaning what is not there. And if you say counts, now counts is a dictionary, .get, that's like string.upper, that's a method. You give it a key and then a default. And if the key exists, you get back what's in the key. If the key doesn't exist, you get the default. Okay? So, and with no traceback, this works. So the best way to think about this is those 4 lines are equal to that 1 line, because X is either going to be whatever was in there before if it exists, or it's going to be 0. Now, the nice thing about 0 is the next thing we're going to do is we're going to add 1 to it, so that's going to get us to 1. So collapsing that loop that we saw before, we can make it just a 1-line loop. And this will become an idiom. This will become something that you will get used to and you will use over and over and over again. And after a while, right now you're looking at it, boy, that's a lot of syntax and semicolons and whatever. After a while, you just type this and not even think about it. It's an idiom. It's basically included in this idiom is how to both create new entries in dictionaries and update existing entries by adding 1 to them. So everything else in this is the same. Name is going to go through these 5 values, and we're going to say count subname equals counts.get name, comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so this is the idea of if new, set it to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0. So that's why we make this default. Now the get can be used for anything. It just so happens that 0 is a common default because it's really common that we're using this to basically make a histogram, right? Little histogram of A, B, C, right? And so we need to make a D, but then the histogram has to start at 1. So that's basically the simplified counting with get. And you know, there's a lot of things that we're going to do inside of Python that do have to do with frequencies and how many times certain things happened. And this pattern is a really good pattern to absolutely know.